Okay, in this video, I'm going to go through a couple segment proofs. We need to use in these some properties of equality. So it's important that when we're doing these proofs that we're using equality and not congruence. This is in your book on page 102. I printed this out because I want to write on it. I don't want to write in my book in pen. So you can kind of follow along with this one and put it in your notes if you, as an example of a segment proof here. Okay, so I'm starting out with this given. PQ is equal to RS. Now what this is saying is the length of PQ is equal to the length of RS. So notice it doesn't have a little line above it. If you saw something like this, PQ is congruent to RS, right? That's a little bit different. It's similar, but this is saying that the line segments are congruent, and this is saying their measurements are equal. Okay, what we can do here is we can put a little tick mark there to say that those are the same length. So the segments are congruent, the measurements are equal. Those are kind of the same idea. The difference is the equality ones we can do algebra on, which you can see there's all kinds of like pluses and minuses, or pluses and equals and stuff. We need to have equality to be able to do that. Okay, so we start out with the given, right? PQ is equal to RS. That's given, these two guys. This segment measurement is equal to this segment measurement. Okay, the next step is a little bit hard to understand, so I'm going to kind of talk about this for just a second. Let me use the addition property of equality in a way that you kind of have seen before. If I had an equation like this, 3x minus 5 equals 10, the first step to solving this would be to add 5 to both sides. Okay, now we can do that, that's allowed, because the addition property of equality says we can do that. If I have something on the left equal to something on the right, and I add 5 to both sides, I get another statement that I know is true. Okay, so that's the addition property of equality. Now let's think about this for just a second in terms of these segments, okay? So I have PQ equal to RS already, okay? Now what I could do here is I can add something to it. I could say, well, what if I add 5, just like I did over here, okay? Now the addition property of equality says that that's okay. I can do that. Now it might not make sense why I would do that in this case, but that's just kind of an example of what I could do. Okay, so I know that whatever PQ is, if I add 5 to it, that's going to be equal to the measurement RS plus 5. Remember, these are just talking about the lengths of certain segments. So let's say that this was like length 10 and this was length 10. Okay, well, if I add 5 to both of them, they're both going to be 15 and 15, and I'm still going to have equality. Okay, in this case, though, what's happening is they're taking this statement, so let me rewrite that, PQ equals RS, and they're adding another length to it. What they're adding, though, is QR. So QR is another length here. So if I go plus QR on this side and plus QR on this side, what I'm going to have here is PQ plus QR is equal to QR plus RS. So this segment length plus this segment length is equal to this segment length plus this segment length. And that's where this is coming from. It's kind of like having two sides of an equation and adding 5 on both sides to get a new statement. I just started with this statement, and I added QR on the left, that's right there, and I added QR on the right, and that's right there. So I added QR, this measurement, to this segment and this segment. Okay, that's the addition property. And if you wanted to add this, it's the addition property of equality. Okay, now I can't do that with segments. Notice these aren't segments, they're segment measurements. So the reason why I can use that property of equality right there is because we're talking about equal lengths, not congruent segments. So going back to this handout that I gave you, what we just used is the addition property of equality. Okay? So with that addition property of equality, it says I can take a true statement like A equals B, and I can add the same thing to both sides. Okay, that's a property of equality, not a property of congruence. Okay, the next part here is the segment addition postulate. Okay, so going back over here to our segment addition postulate, What this says here, this is a little bit cut off, but this is a point C over here. Okay, it says if B is between A and C, which it is, then the length of AB plus the length of BC is equal to the length AC. So I can use these two measurements here, these two small measurements, add them together and get the length of the big guy. So here what we're saying is if I wanted to get the length of PR from this guy to this guy, that length is equal to the length of the little guy, PQ, plus the length of QR. So PR, the length of that segment, is PQ plus QR. And that's right here. It's a little bit in a different order, but the same idea. If I take PQ, the measurement there, and I add it to the measurement QR, I get the measurement of PR, from P all the way to R. That's what this first guy is saying. Okay, the second guy is very similar, but it's using the other two pieces. So if I take QR, this one, and then I add it to RS, the measurement from here to here, I'm going to get this from Q to S, the measurement from Q to S. That's this guy. Both of those are using the segment addition postulate. Okay, so if you notice, PQ plus QR is right here, and QR plus RS is right here. So I can replace this PQ plus QR with this guy, and I can replace this with this guy. So QR plus RS, that's this, QS. And PQ plus QR, PQ plus QR, that's this guy. So this I can replace with PR, and this I can replace with QS. And that's what we have here. PR is equal to QS. Okay, what property is that using? That's a substitution property. And remember, substitution is not a property of congruence, it's a property of equality. So I'm going to make that note here. Okay, and that's what we set out to prove. We wanted to show that the measurement PR was equal to the measurement QS. Okay, so we used this property of equality, addition property of equality. We also used a substitution property of equality and a postulate to prove this statement was true. All right, so we got property, postulate, property. These are all things that we can use as justifications. Okay, let's do one more here. All right, this is on page 103 of your textbook, and it's a fill-in-the-blank proof. So some of this is already written out for us. Okay, now the difference between this proof and the last proof is what we're given. Okay, notice that these are congruent statements, not equality statements. It's kind of hard to see, but this is, right here, this is a congruence, congruence, and congruence. So we got one of these guys. Okay, now we can't do addition with or substitution with this symbol. So we start off with the given information here, right? So what goes here? Basically what we're given. PQ is congruent to RS, QS is congruent to ST. So I'm just going to fill this in right here. So PQ is congruent to RS, QS is congruent to ST. Basically what I have right here. Okay, now the reason for that is given. Now what happens in this next step is I change this congruent statement into an equality statement. So PQ and RS, these are segments, and there's a congruence. Here's a PQ and an RS, but this is a measurement because it doesn't have that line over it, and this is an equal sign. Okay, here's a segment congruent to a segment. Here's a measurement equal to a measurement. So what we're doing here is we're translating from a congruent statement to an equality statement. The justification for that, or the reason we can do that, is the definition of congruent segments, right? Congruent segments mean they have the same measure. That's how I can transfer from congruence to measurement, okay? Now the reason I want to do that is because I get all kinds of properties of equality that I can use, like addition property and substitution property, okay? This next one here, what's happening is we're saying PS, this whole guy, is equal to the measurement of this segment, PS. Sorry, I'm looking at this guy right here. Is equal to PQ, this measurement, plus QS. So the measurement of the whole segment, PS, is equal to the measurement PQ plus the measurement QS. Okay, right here, the second statement, RT, this whole thing, RT, is equal, the measurement is equal to RS, this measurement, plus this measurement, ST. Okay, that's the segment addition postulate we just talked about. Okay? All right, the next thing it's going to be using is properties of equality. So this is addition property of equality and the substitution property of equality. Okay? Now my goal is to say that the segment PS is equal to, or is congruent to the segment RT. And so I need something that's going to allow me to set that up. Okay, so let's talk about this, the addition property of equality. All right. So what I have here is I have PQ is equal to RS. Okay, this is one of my statements from earlier. PQ equals RS. Okay, now what I could do if I wanted to is I could add QS to this side and I could add QS to this side if I wanted to, because I'm adding the same thing to both sides, right? But if you think about it, QS is equal to ST. I already knew that. So if I wanted to add QS on one side, I could add ST on the other side, and that would still be true. Since QS and ST are equal to each other according to this, I can add QS to this, and I could add ST to this, and that's going to give me a true statement. So basically what I'm doing is I'm taking this statement, PQ equals RS, and this statement, QS equals ST. Again, that's from part B. And I'm adding them together. So on the left, I get PQ plus QS. And then I have equals, and on the right side, I have RS plus ST. Okay, this is the statement that I'm going to use right here for D. This is the addition property of equality. It's kind of hard to see that, but I'm basically taking a true statement and I'm adding equal measurements to either side. I'm adding a QS on this side and an ST on this side, but since I know they're equal to each other, I can still do that. This is like taking an equation and adding a +5 and a +5. So this statement right here, statement D, is PQ plus QS is equal to RS plus ST. And that's the addition property of equality. Okay, I couldn't do that with congruence. This is only a property of equality, not a property of congruence. Okay, now check this out. PQ plus QS is right here. And RS plus ST is right here, right? And I know this thing is equal to this thing. So I can replace this, PQ plus QS, with this guy, PS. And I can replace this stuff right here, this stuff, with RT, since they're equal to each other. So this guy is PS is equal to RT. Okay? Now that's a substitution property. That's a property of equality. Right? Couldn't do that with congruence. And I'm almost there. I've just shown that this guy, PS, the measurement, is equal to RT, the measurement. Okay, now the last thing I have to do is just show that these are congruent, and I can do that. If the two measurements are equal, then the two segments are congruent. That's, again, the definition of congruent segment. Okay? So notice that I do some algebra in the middle here, right? These steps right here, these middle steps. I'm using properties of equality in order to add these measurements together, right? If I'm going to use measurement or addition, I need to be using measurements here. But I start with congruence and I end with congruence. So in order to get from congruence to equality, I have to use this definition of congruent segments. I actually use it twice. I use it once to go from congruent statements to equality statements, and then I use it again to go from an equality statement back to a congruent statement. So that's kind of my bridge in between the two. in the middle, I'm using properties of equality to do some like algebra kind of stuff. And that's kind of the end of that proof. So that is an example of what's going on in this handout. Okay. Remember that I have more properties of equality than I do properties of congruence. All this add, subtract, multiply, divide, substitute, distribute, all those kind of things, they only work for equality. So if I'm given a congruent statement, which I was in this proof, I have to translate it over to an equality statement so that I can use all my algebra stuff. I can use all my algebraic properties to manipulate. So we're going to work on some more of those proofs, and we're going to apply that to angles as well in our next lesson coming up. But this bridge here between congruence and equality and going back and forth between these two, understanding that there's certain properties that you can only use for equality, that's a pretty foundational concept. So I hope that helps. If you need to go through those proofs again, you can look up you can look those up in the book and kind of go through some of those examples, but that'll help you to kind of get ready for where we're headed on Wednesday and Thursday.